All right, we're going to be talking about triangles for quite a while now, and just to give you some basics about triangles, we're going to review how we classify them. So, a scalene triangle, remember that means that there are no congruent sides. All sides are different sizes. And in the isosceles triangle, there are two sides that are congruent. So notice that this one has two. And equilateral has all sides congruent. All three sides are the same size. And remember, we can also classify triangles by angles. So I can have an acute triangle, and that's going to have all three angles being acute, smaller than 90. I can have a right triangle, and that's when we have one right angle in our triangle. And then I can have an obtuse triangle, and that has one obtuse angle. And if I have an equiangular triangle, then I have all three angles are congruent. So let's talk about those angles of a triangle. If we take a triangle, and if I tear it apart so that I've got those angles separated, here's what I'm going to do. I'm going to line these up so that 3 is over here. I'm going to line up angle 1 right here, and then I'm going to flip angle 2 around, and notice that it fits right in there. So why am I doing this? Well, if you notice that these were the angles of the triangle, and all three of them added together makes this straight line. So we know that a straight line is 180 degrees, and that means that all of the angles in a triangle add up to be 180, which is what this theorem says, the triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180. So in this picture, that means that angle A plus angle B plus angle C, those all add up to be 180. Now we're talking about interior angles of a triangle, so I want to be clear. The interior angles of a triangle are the ones that are inside of the triangle, interior angles. So we're talking about, like in this diagram, angles 1, 2, and 3. These. And I think that's pretty apparent. But what else I want to talk about are exterior angles, and those are the ones that make linear pairs with those interior angles. So I'm talking about like angle 4. Angle 4 would be a linear pair with 1, and so would 5. So those 4 and 5 are exterior angles. 6 and 7 would be exterior angles, and 8 and 9, those would be exterior angles. So the reason we care about those is because we have another theorem about the exterior angles. So the measure of an exterior angle of a triangle is equal to the sum means I add them up, the sum of the measures of the two non-adjacent interior angles. What does that mean? So here, angle 1 is my exterior angle. Notice it's laying outside. It's a linear pair with this angle 2. But the non-adjacent one, so angle 2 is adjacent to that. That's what makes it a linear pair. But the non-adjacent angles are going to be angles A and angle B. So this theorem says that the measure of angle 1 is going to be the same as A and B added up together. And let's think about why that makes sense. So we know that angle 1 and angle 2 are a linear pair. They add up to be 180. And we also know from the theorem we just said that all the angles in a triangle add up to be 180. So that's A, B, and this angle 2 here. Those all add up to be 180. Now, if both of these equations equal 180, then what I can do is set those equal to each other. So I know that A plus B plus 2 is equal to angle 2 plus 1. And if you notice, on each side of the equation, I have an angle 2. So we can subtract angle 2 from each side. And if you do that, then you just get A plus B. And over here on the right-hand side, you get angle 1. So that just proves that this theorem is correct, and it makes sense. So let's do an example. So if we look at this diagram at the right, we need to find the measure of DCB. That's this angle, the 3x minus 9 angle. So first of all, we're going to use that theorem. We are given that exterior angle, and we are also given information about these two interior angles that are non-adjacent. So I'm going to set 3x minus 9 equal to 73 plus x, and I'm going to solve. So I'm going to subtract the x from both sides. That's going to give me 2x minus 9 equals 73. Then I'm going to add the 9 to the other side. That's going to give me 2x equals 82. And then divide both sides by 2. And that gives me x equals 41. Now, be careful here. It didn't ask for x. It asked for the measure of angle DCB. So I need to plug 41 back into this expression for DCB. So I need to say 3 times 41 minus 9. I plugged in that 41, and that gives me a total measure of 114. So DCB is 114 degrees. Now there's a corollary to that triangle sum theorem. Corollary just means it's a theorem that's very closely related. And that just means if we have a right triangle, so this only works with right triangles, then the acute angles of a right triangle are complementary. What does complementary mean? Well, that means that these two angles add up to be 90. So again, let's think about why that makes sense. So we know that all of the angles in a triangle add up to be 180. So that's angle A plus B plus C. Those all up to be 180. Now in a right triangle, angle C is specifically 90 degrees. So I'm going to substitute 90 degrees in for angle C. And if I subtract 90 from both sides, then I get A plus B is equal to 90. And that's what that theorem is saying. So again, let's do an example. We've got this wheelchair ramp, and it forms a right angle right here. And the measure of one acute angle in the triangle is 8 times the measure of the other. So think of it as like if there was a code, then it said that this angle has to be 8 times as large as this angle so that the ramp's not too steep. Okay, then that would mean we don't know what this angle is, so this angle is x, and this angle would be 8 times x. So we're trying to figure out how much are these angles supposed to be. So this is a right triangle, so we know that 8x plus 1x equals 90, because this is a right triangle. Those two angles are complementary. So we combine our like terms, we get 9x equals 90, and then we solve and we get x is 10 degrees. That means that the other angle has to be 8 times as big, which is 80 degrees. Notice that both of these 80 plus 10 equals 90 degrees. So that's how we can use all of the sum properties of triangles to help us solve problems.